This question gives you 3 molecules to draw Lewis diagrams for. We're starting with a chemical called ethine. You're going to start with an NASB table. You start with carbon, which needs 8 but only has 4. And you have another carbon, which needs 8 but only has 4. Then you have a hydrogen, which needs 2 but only has 1. And you have another hydrogen, which needs 2 and only has 1. And when you add them up, you need 20 electrons, but you only have 10 electrons. So you subtract the A from the N, so you are going to share 10 electrons. Since each bond contains 2 electrons, you're going to have a total of 5 bonds or 5 lines. So you're going to start by drawing the central atom, at this point both carbons, and a hydrogen with each carbon. Draw a single bond between everything, and that actually uses up 6 electrons. You now have 4 electrons left to place. You're going to place them in pairs around the carbon because the hydrogen can't take any other electrons. And in this case, I put the 4 electrons here. I now have no electrons available, but you notice that this carbon doesn't meet the octet rule. It only has 4 electrons. When that happens, you're going to need to share more electrons. You're going to take these 2 electrons and move them to form another bond between the 2 carbons. And now you have something that looks like this. But that same carbon still doesn't meet the octet rule. It has 3 lines going to it, or 6 electrons. It still needs 2 more. So you're going to take these 2 electrons and slide them between the 2 carbons. And so now you have a triple bond. And when you do that, this carbon sees 2, 4, 6, 8 electrons. And this carbon sees 2, 4, 6, 8 electrons. The hydrogens each see 2 electrons. The octet rule is met. Everything is good. So then we go to boron trichloride. We're going to follow the same set of rules. Set up an NASB table. We have one boron, which needs 8, but has 3 valence electrons. I wrote all the chlorines down at once. Each one needs 8. Each one has 7 available. So when you tally things up, you need 32 electrons. You have 24 available. So you're going to need to share 8 electrons or produce 4 lines or 4 bonds. But if chlorine is not the central atom, it will only form 1 bond or only have 1 line. So the NASB doesn't make sense here. It says I need 4 bonds, but I can only make 3 bonds. We need to break the octet rule. You're going to start in the same manner. You use the less electronegative element as the central atom and surround it with the other atoms. Draw a single bond between the central atom and the outer atoms and subtract those electrons from the available. 3 lines, 6 electrons. There are 18 electrons left to place. Now, placing electrons in pairs beginning with the outermost atoms, you're going to get the outermost atoms to fulfill the octet rule. So you place those around and you see that you've used up all 18 electrons. There are no other electrons to utilize. Now here you might think about sliding these 2 electrons down here to form a double bond, except chlorine, when it is the outermost element, doesn't form double bonds. So that cannot be done. So we're left with this, and this is called an incomplete octet. The final compound you're asked to draw a Lewis diagram for is phosphorus pentachloride. Set up the NASB table. There's your phosphorus. There are all your chlorines. You see that you need 48, but you have 40. So you need to share 8, which means you need 4 bonds. And that obviously makes no sense. The NASB table says you need 4 bonds, but you have 5 chlorines to bond. When the NASB table doesn't make sense, you're going to break the octet rule. But you start off the same way. Put in the phosphorus and surround it with the chlorines. Draw the single bond between the chlorines and the phosphorus. There are 5 bonds, so you've used up 10 electrons. There are 30 left. So now you're going to place the remaining 30 electrons in pairs, beginning by placing them on the outermost atoms. So when you're done, you look like this. You've used up all 30 electrons, and there are no more to place. The chlorines all fulfill the octet rule, but the phosphorus has more than an octet. This is called an expanded octet, and this is the most common exception to the octet rule. So this answers the question.